Hello, and welcome back for lesson 7.4. There are going to be two videos for this lesson to break it up. And we are going to start with the topic of mutually exclusive events. So mutually exclusive events are two events that cannot happen in the same trial of an experiment. So I'm going to give some examples here, and hopefully that clarifies a little bit better. So it says, determine whether the following events are mutually exclusive. Owning a dog and owning a cat. Because you can own a dog and a cat at the same time, they are not mutually exclusive. Being a business major and being from Texas. Because you can be both at the same time, they're not mutually exclusive. Being retired and being 70 years old. You can be retired and be 70 years old. So they're not mutually exclusive. Being a teenager and being 70 years old. You cannot be them at the same time. So they are mutually exclusive. Being one of the 10 tallest people in the US and being under 4 feet tall. You cannot be those at the same time. So they are definitely mutually exclusive. And then being male and being a nurse. You can be a male and a nurse at the same time. So they are not mutually exclusive. Okay. So we're going to do several examples in this lesson and also the next lesson, 7.5, where we talk about rolling two dice and the outcomes of the two dice and different things about them, usually the sum of the two dice. So this is if we were rolling dice one, you can have a 1 through 6, and this is if we were rolling dice two. And let's just say we rolled them at the same time, and let's say there were two different colors, so you could definitely identify which one was dice one and which one was die two. So to get a 1 and a 1, you're going to have a sum of 2. That's the only way that you can have a sum of 2. If you roll a 2 and a 1 or a 1 and a 2, then those are the only two ways that you could get a sum of 3. Okay, so you're going to get a sum of 3. Let's go over here. The only way that you can get a sum of 12 is if you roll a 6 and a 6. So the lowest sum that you can get is a 2. And highest sum is a 12. And because there's 6 options this way and 6 options that way, there are a total of 36 outcomes. Here, the one that is most likely is the sum of 7. Because you can see here, it happens 6 different ways. 6 and 1, 1 and 6, 5 and 2, 2 and 5, 4 and 3, and 3 and 4. And then there's also all of these outcomes here that are doubles. So a sum of 2 is a 1 and 1, 2 and 2 is a sum of 4, 3 and 3 is a sum of 6, 4 and 4, and so forth. So let's just go ahead and answer some questions regarding this table. 2 dice are rolled. Find the probabilities of rolling the given sums. So the probability of rolling a 2 would be the number of outcomes that are a 2 out of the sample space. Okay, so that would be, this would really be the number and would be the number in S. So the number of 2s, there's only one way you can get a 2, and there's a total of 36 outcomes. The sum of 4. So that would be a 3 and a 1, a 2 and a 2, or a 1 and 3. There are 3 ways that you can get a 4 out of 36, and that can reduce to 1 out of 12. A sum of 6. So a sum of 6 are all of the ones on this diagonal here, and there are 5. There are sum of 6 is 5 and 1, 4 and 2, 3 and 3, 2 and 4, 1 and 5. So there are 1, 2, 3, 4, 5 out of 36. And then 9 or more. And 9 or more means that we're including the sums of 9, 10, 11, and 12. 9 or more. So the sum of 9 happens here, 6, 3. So everything here and beyond. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 10 out of the 36. And we can reduce that by a factor of 2. So that becomes 5 out of 18. The next one is less than 7. So all the sums less than 7 would be the 6 and below. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 out of 36. We can reduce by a factor of 3. So we have 5 out of 12. The next one, between 5 and 8, exclusive. So that means that we're looking at sums of 6 and 7 because we're excluding 5 and 8. So 6 and 7 would be 6 would be 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 11. 11 out of 36. And the last one says the second die is 5 or the sum is 10. So the second die is 5. So we're looking at here. So any of these 1, 2, 3, 4, 5, 6. So there's 6 out of 36 there. Plus the sum is 10. So the sum is 10 would be right here. 1, 2, 3 of them. But remember, if any of them overlap, which we do, 5 and 5 was in the column of 5, and it was also in the diagonal of 10. So we have to subtract that 1 so that we don't count it twice. So that one should be 6 plus 3 minus 1 is 8 out of 36. And we can reduce that by a factor of 4 to 2/9. Page. We're looking at a deck of cards. And in a deck of cards, there are 52 cards. There are 4 suits, they're called. And those are the shapes. So there's hearts, diamonds, spades, and clubs. You can't see it here, but these two are red. Hearts and diamonds are red. Spades and clubs are black. And there's 13 cards in each suit. Okay. So we're going to use these cards to answer some questions. So it says one card is drawn at random from an ordinary deck of cards. Find the probabilities of drawing the following. So you're drawing a 9 or a 10. So there are 4 9s and there are 4 10s. So that means there are 8 out of 52. We can reduce by a factor of 2 to get 4 out of 26, but we can reduce by another factor of 2 to get 2 out of 13. And then a red card or a 3. So a red card. And I just want to show you that we're actually using the union probability rule, which we've kind of used before, but we're formally bringing it up in this lesson. It's on the next page here. The union is an OR. So whenever there's an OR, we're taking the probability of event E plus the probability of event F, and we're subtracting that intersection. So the intersection, I called it overlap in another lesson earlier. So we're subtracting that overlap. So I'm going to show you that here because we're asking for a red card or a 3, and you could have a red card that is a 3, so there is overlap. So there are 13 red cards. Actually, there's 26 red cards because there's hearts and diamonds. Plus, that means there's 2 that are 3s. I'm sorry, there are 4 3s total. And then there's 2 that overlap because there is the 3 of hearts and the 3 of diamonds. So we have to subtract those 2. So we have 26 plus 4 is 30, minus 2 is 28 out of 52. And we can reduce this by a factor of 4 to be 7 and 13. Why don't you just take a break, pause it, and I want you to try C, D, and E on your own, and then we'll work on them together. A 9 or a black 10. So a 9, there are 4 9s. A black 10. So there are 2 black 10s of 52. And then a 9 and black 10, there's no overlap there, so we can just add them together. So that is 62, or sorry, 6 out of 52. And we can reduce that by a factor of 2 to be 3 over 26. And then a heart of a black card. I think that's supposed to be heart or, is what I meant to write, a heart or a black card. So yours will be corrected. So a heart would be 13. And then a black card, there are 13 spades and 13 clubs. There's actually 26. They don't overlap, so we don't even have to worry about any subtraction. So there are 39 out of 52 that satisfy this, and that reduces to 3/4. And then a face card or a diamond. So a face card. So face cards are cards that have faces on them. So those are the jacks, the queens, and the kings all have a person's face on them. So there are 12 of those total. Plus diamonds, there are 13 diamonds. And then we're going to subtract a diamond that's a face card. So a diamond that's a face card, there's jack, queen, and king. There's 3 of those. So that should give us 12 plus 13 is 25, minus 3 is 22 out of 52, and that reduces by a factor of 2 to be 11 over 26. And we're going to look at, so we've already had this topic of the union rule. Now we're going to also add in the complement rule. We've talked about complements and we've kind of used them before, but they formally bringing it up here in this lesson. So the probability of E is equal to 1 minus its complement. And the probability of the complement is 1 minus the probability of E. And what they don't show, but they should, is that the probability of E plus the probability of its complement equals 1. So if you know one or the other, you can subtract from 1 to get the one that's missing. So let's look at example 4. Example 4, they tell us the probability of E is 0.26. The probability of F is 0.41, and their intersection is 0.16. So for me, I like using a Venn diagram. It's just the way my brain have a picture. So use what makes sense to you. If the formula works, then just use that. But I'm going to draw E. And because there is an intersection, I know that they overlap. So E, F, and then here is my union, my whole set here. not union, but my whole set U. And out here is everything that's not an E or F. So the intersection is 0.16. And so if E is 0.26, all of it, 0.16 is in this intersection part. That means that 0.26 minus 0.16 is 0.10. So that is right here. And then if F itself is 0.41 and the intersection is 0.16, that means that everything else here in F is 0.25. And then if we add these three pieces together, 0.10, 0.16, and 0.25, we get 0.51. So that means that everything out here is equal to 1 minus 0.51, which is 0.49. That just kind of sets me up to be able to answer some questions. So let's look here. A says, what is the probability of E union F? So E or F. So we can do this in two ways. We could either add E to F and subtract the overlap. So that works. Or we can just, we've already got them individually separated out. This is E without the intersection, F without the intersection, and the intersection. So if you add all three of them, you get 0.51. So B says intercept. So we want to know only what is in both. Something that's not an E. So everything that's not an E. So everything that's in the yellow and then over here in F that's not part of E, intersecting with F. So that would have to be just this 0.25 space. Now we're going to do the opposite. So C says the probability of E intersecting with not F. So that's the yellow, but it has to intersect with not F. The yellow and right here in E, the moon shape here, that's intersecting with not F. So that has to be just the 0.10 right here. And then D says we want a union, so everything together that's not an E or it's not an F. So everything out here is not an E, and then everything out here is not an F. So essentially, we're just not going to have the intersection. So that would be 1 minus the intersection of 0.16. And so that would be 0.84. 0.84. Excellent. So catch me back for the second video for this lesson 7.4.